All right, so this is project 10. We're going to download IMU, GPS, and video all from the Raspberry Pi to our host, and we're going to send it over Wi-Fi. The requirements are similar to the last three projects. The main difference here is that we're going to be sending our IMU data from our Arduino to our Raspberry Pi over I2C. And then we'll do GPS and USB webcam just as we did in previous modules, and we'll send all of that information over Wi-Fi so that as the quadcopter is flying, we can stream all of this on the host at the same time. For the design, we didn't need any new hardware that we haven't already seen. We just need some extra jumper cables so we can correctly wire the Arduino to the Raspberry Pi. The wiring for the BNO 055 sensor that's going to collect our roll, pitch, and yaw data is the exact same as the last two projects, so I won't go over that. But the wiring from the Arduino to the Raspberry Pi is important. So this is a wiring map of the Raspberry Pi. The three pins we care about here are the SDA pin, pin 3, the SCL, which is pin 5, and then ground is pin 9. And then I have a Mega 2560, so I have an extra SDA and SDL pin that I'm not using for the BNO 055, and those are above the AREF pin. And so my wiring is as shown. So here we have our Arduino wired to the Raspberry Pi via I2C. So we're using the I2C1 pins, so that's pin 3 here, pin 5, and then this is ground. And so this brown wire is connected to, you can see it on the side here, sorry. That brown wire connects to SDA, and the red wire connects to SDL, which is, those are the corresponding pins on the Pi. And then the black wire is connecting to ground. And then we've got our BNO 55 wired up as it was before, and the Arduino is being powered by the Raspberry Pi. And we're actually going to put the Pi in its case and just thread these wires through, but I just wanted to show you the setup before we do that. Once the case is back on the Raspberry Pi, we attach everything to the quadcopter. I've got my webcam and my GPS on top, and then the Arduino and the BNO 055 and the Raspberry Pi and charger on the bottom. That's a lot of weight, but it does still get off the ground. The software is pretty straightforward here. We're going to set up the Raspberry Pi just as we have in the past, and then we need to set up the Arduino so it sends its IMU data over I2C. So we're going to upload this IMU over I2C sketch, which we'll go through now. All the steps for getting the roll, pitch, and yaw data from the sensor is the same. We're going to set the address of the Arduino to 4. This will be the slave, and the Raspberry Pi will be the master. We'll make some character arrays for the IMU data. Most of the work here is just done in this wire.write, and then we're going to write the IMU data to the I2C in this send IMU data function. So on request from the master, we will send the IMU data, and that's the important part right there. And what is the IMU data? Well, we're going to structure it in a way that one of my classmates did. We're going to put our roll, pitch, and yaw data as 3 strings separated by this OR bar, and that's how we'll parse it out once we get onto the Raspberry Pi. We're going to have to set up the Raspberry Pi for I2C. So we will enable the I2C port, which is pretty easy in the Raspberry Pi config settings. We're going to install the I2C tools, and then we're going to check that our Arduino is connected correctly. So we're going to run this command here. It's sudo I2C detect Y, and ours is I2C1. And so we can see here that address 4 is taken by our Arduino. And then we'll look at the read I2C.py script, which we're going to use to read the data here. We're going to import the SMBus module, which is the main part of this. We know the address of the slave, and then the main function is to read the I2C block data, and then we're just going to parse that data and print it to the screen. So it's very straightforward. And when we run this function, we see our yaw, pitch, and roll data in a moment. There we go. So our raw yaw, pitch, and roll data, as I move the quadcopter, we see that it changes, and I've already got the motion software running, so you can see up in the top left corner as I move the quadcopter, the camera moves as well. And then for GPS data, we're going to run sudo GPS. We've got our lat and long, and I had that GPS read function from last time, which we will run here. and that pulls in the lat and long data. So now we can see all three are streaming on our host laptop. So all that's left to do is test out our quadcopter as it flies.